Ladies and gentlemen, boys and girls, my name is Subrata Sarkar. I'm a mechanical engineer working in manufacturing industry more than 22 years. Today, I'll share one of my very interesting topic, that is machining. Now, machining means actually removing the material from metallic material. We conventionally in engineering industry we call it machining. Now, I'll discuss one of the special technology of the machining, that is a cryogenic machining. Now, before that, what is cryogenic actually? The word cryo comes from Latin word. It's called, cryo means cold. Now, how much cold then you can call it cryo? So, cryo is basically in a level of minus 180 to minus 200 degrees centigrade temperature range. That is called a cryogenic. So there are commercially available material like liquid nitrogen is one of the most popular cryogenic commercially available material, which is used in very many applications of industry. So today I'll discuss one of the application area of the liquid nitrogen. You can say this is a cryogenic machining process actually. Now then, what is machining actually? Those who are not into engineering industry, this is for them actually. Say you want to remove some material to give some desired shape to a metallic material. Say a 100 millimeter diameter steel rod you want to cut in different shapes. So this will be a machining process. Here you can see. Now if the rod is held on a machine which is rotating at a very high speed, say 1000 RPM, and you touches one tool, this is technically called tool, cutting tool, then the skin of the material will be removed this way. This is called basically machining process, and technically it is called turning process, which done in a machine called lathe machine. You'll find in many workshops. This is a very basic process of machining. Now when the high speed metallic material is rotating and you are touching another metallic material which is harder than that, then there will be heat generation immediately, and that tool material will be blunt and it will not able to cut the material. So you need to give some liquid water or something, so that the temperature at this zone, touching zone, will be reduced actually, so that the tool can able to cut. Now if you put only the water actually, it will not work basically, because water will evaporate immediately. Instead, if you mix some chemical which is called conventionally called coolant to this water, then water will look like a milk actually. Then it has got a heat absorption capacity. So this is the conventional way metal machining is done in engineering industry. Like giving a coolant when do the machining, so that your productivity will improve, your tool life will increase. This has been happening since decades actually. Now in some of the advanced industry, those who are very much concerned about the environment actually, they have started using liquid nitrogen in place of the water with coolant. And which has got, and it will be next 20 years, 50 years, maybe liquid nitrogen will be the only things actually which will be used to take care of the environment, because it doesn't have no pollution, nothing actually. Now in this picture, this same machining operation is going on, but it looks like a frozen, some ice is frozen. Is basically liquid nitrogen is given, and liquid nitrogen is so cold, if you just spray it into the air, immediately it got into frozen, actually looks like a ice actually. So this is basically the way liquid nitrogen is given in different metallic and non-metallic material. You can see here the machining process is going on. So when metal cutting operation is going on, liquid nitrogen is spraying through the system inside the tool or externally from the tool, and this machining operation is going on, and it has got a lot of advantages. This is the latest actually metal machining during this liquid nitrogen process. And because there is the effects of liquid nitrogen, if you say, because in metallic material, if there is a major temperature change, there is a possibility that there might be some metallurgical changes, which may be positive, which may be negative. So we need to understand what happens if the minus 200 degrees centigrade liquid is sprayed on a metal, which it is going to machining. So following the important point, actually if you do this cryogenic machining on a metal, your tool life will increase like anything actually, because tool doesn't get heated, and the surface roughness surface finishing is much better than conventional machining for the same parameter, and the dimensional accuracy is much more. Many times what happens, you are doing a machining of a big job, say this much of hole you are doing machining, and due to the heat generation or something, there is a dimensional fluctuation, because when you are doing the machining, there is some temperature, 100 degrees centigrade, and when it got cold, then it may be 20 degrees centigrade, so there is a dimensional deviation. The dimensional deviation for many reasons actually doesn't happen with the cryogenic machining actually. And liquid nitrogen has got a lower frictional coefficient with the cutting tool actually. This is one of the reasons. And when you do the metal machining actually, there is a things which come out is called technically chip. Now you'll find that when steel is machining, there is chips are coming out like a springs or something. And if liquid nitrogen, and it's a problem with the machining, if the chips are much longer in length, so there are a special arrangement in the tool normally happen, it's called Chipbreaker. But if you do the liquid nitrogen machining, you don't need any Chipbreaker, as there is a very cold temperature, the chip got automatically breaks into small parts, and it's a favorable condition for machining. And if you see this surface roughness quality here, like this machining with liquid nitrogen gives much more balanced surface finish actually. So if you summarize the benefits of the liquid nitrogen machining process or the cryogenic machining process, number one, it is a sustainable method actually. It is take care of the environment friendly, rather you can say it increase the material removal rate actually. You can give more depth of cutting speed of the tools for the same tools with respect to the conventional cutting. So obviously it increases the productivity in all respects, like it takes less time to cut the material, it increases the tool life in a great way actually, significantly high tool life actually, if you do the machining with liquid nitrogen. So if you find this presentation is interesting and informative, you can share it with your friends, and if you have not yet subscribed my channel, you can subscribe my channel by clicking on this bell icon. Thank you so much for your attention.